Can someone close the door at the back? All right. Welcome everyone to the last lecture of the semester. Last lecture. So this today we won't have any new material. In the first hour, we will finish the last tutorial for the Boolean algebra. Okay. And then I will discuss. If last week I didn't say anything clear, this week I'll repeat again. Again, when we discuss the question. And then second hour, we will basically run through the content for final. Okay. Run through the content of the midterm. And then maybe give some hint on what should you focus. And third hour, we will discuss the quiz from last time, and then anything you want to ask about. And I also pull out some review questions. If you have tried, we can discuss. So people online also can type, or you want to shout out also. I think she is sick. And I think she is sick, so she cannot make it in person. Okay. Anything? Anything you want to ask first? If not, we run into a quick tutorial first. Yeah. Try discuss with your friend. Look up the tutorial. Try to do tutorial. Then after tutorial, we'll discuss the question. Then finish the tutorial question before you come. Anyone finish? No. Yeah, try spend maybe half an hour discuss. You can jump the question. Don't need to do all of it. You can jump the question. Okay, maybe this type of question you do one, and next type of question you do one. Then later when we discuss, then you will know more or less what I do. 不需要看他的手势，他可能要看他的。 One KMF question at least, okay? Try to do it now. Try to do KMF question. Later I'll discuss. Try to do one KMF question. Hmm? Yeah, try some question from 12.4 again. Then later when I explain, you don't get lost. Yeah. 因为它这个写法的话，它有转折。放过要 Okay. 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 I see a lot of you haven't do revision yet. You're doing revision, but make sure you do revision before final. Okay, maybe we go through the question so that when I pull out the solution letter, you can study. You will know what I'm doing. If you know, you can keep going with your tutorial. If not, I will start explaining the question. The 12.1.35. So 12.1 are all basically about Boolean algebra. Okay. So 12.1.35 asks about idempotent law. Yes, okay. So we are asked that prove every x in the algebra x or x equal to x. Okay, so you are only given 5 laws in the algebra. You need to produce this idempotent laws. Okay. So how do you prove it? So there are only 5 laws you can use in Boolean algebra. Everyone can see. Need to turn off. You need to turn off the light. Can see? Or you want to turn off the light? Turn off. Turn on or turn off? Turn on. Turn off. Okay, turn off. Oh, on. Okay, okay. Okay. Yeah. So idempotent law. So how do you prove these two theorems here? So you need to think of one way to create another x. Okay. So how do you create another x? So you first make the zero appear first. But what is zero? Zero is x and x bar. So what you need to remember is the p and not p. Right? P and not p is always false. Okay, this is how you remember. So it's called the complement law. So you can create two elements from the zero. And then after you create the two elements, then you can distribute it. And then you can see that when you distribute, this is the one you want. Okay? But you also have a jump here. Okay? Luckily, this jump here will become one. Okay, so when you take any element n or cap with one, you will get that yourself. Okay, so you create something from nothing. So this is the how you play around with this algebra. So the 0 and the 1 is very important because they can use them to create something. Okay. So that's why we are interested with these identities, 0 or 1. Okay. But 0 and 1 you can create element. I think similarly you can prove x and x. I think I haven't wrote it down yet. Any question on this proof? Yeah. This is a similar flavor for 36 and 37. I won't discuss similar flavor. So only using 5 law. And then the key is the 0 and 1. Use 0 and 1 to create the thing that you want. So that's why we are interested with these identities, 0 or 1. Use 0 and 1 to create. Okay, I won't discuss these two because it's the same level. The next one is circuit. Yeah, this circuit is just testing you whether you know the gate or not. And then make sure you know that whenever you see some expression here, this kind of expression, there's some gate should appear behind your mind. Okay. That's why that's about this topic here. We want to reduce this gate. Reduce the use of the gate. Okay. So whenever you see some expression like this, you should remember there's a gate behind it. There's some combination of gate. And then you want to ask the question whether you can simplify the gate or not. Okay. So this one should be not too hard. Okay. Anyone not know this gate? So you should like put in different 1, 0, 1 and produce some result here. The function, truth table function. Okay. I think you shouldn't forget about it. Truth table function. Make sure you know how to construct. Okay, this one is the key. You should spend more time on it. This is the 2.4 is the key of this topic here. I can go deeper if you want because last week maybe I don't explain well. So there are more examples this time. Make sure you do it. So 12.4.2, what is it? Find the sum of product expansion represented by each of these K-maps. Okay, so you are given the K-maps. Oh, this one is just how to read the how to read from the K-map to the expression, and then how to even an expansion produce a K-map. Okay, this is the basic thing to construct K-map. Okay, this one your classmate say I know how to simplify, but I don't know how to use K-map. But I need to tell you that the question I ask is like specific. Ask you to produce the K-map, so you have to use the K-map to simplify. Even though you know how to simplify, maybe you won't get the full mark. Okay, so you must know how to use the K-map, how to produce the K-map. Okay, so how many ones? So there's a characteristic here you need to take note. How many one in the K-map represent how many minterms here? Okay, so you have 3 minterms here, you should have 3 1 here. You have 2 minterms, you should have 2. You have 4 minterms, you should have 4 ones here. Okay. So this is to check whether you construct the right K-map or not. And then put the 1 at the right minterm. Okay. This is like a table of product. So the first one is xy, the second one is xy bar, third one is s bar y, and then fourth one is s bar y bar. Okay, so this one is create the K-map. And then 12.4.4 is to teach you how to use the K-map. Okay, so Remember the block you can put is power of 2. Okay. The block you can put is only power of 2. For example, 1 times 2, product of power of 2, or 2 times 1, 2 times 2, 4 times 1, 1 times 4. Yeah. Okay. Only power, product of power of 2. So why I can produce this block here? Because this 2 is x bar y plus x bar y bar. By algebra, you can factorize and simplify it. X plus x bar become 1. Okay, where you get x bar. So your classmate say, I know how to do this. Is enough. Okay, but you need to use Kemet as well. Okay. So make sure you know how to do this block, how to label. Make sure when you label, they have to be differ in 1 liter. Okay. Let me show you in higher, yeah, in this case. So when you make sure these two, when they are adjacent, okay, they have to be differ with 1 literal only. Okay, for example, yz and yz bar. Y is the same, but z is different. Only exactly 1. Okay, so you cannot put y bar z bar here. Okay, why? Because you differ in 2 literal. Okay, they are not adjacent. You cannot put y bar z bar here. So no matter what you start, you can even do yz bar, y bar, z bar, y bar, z, and yz here. You can do this. This is also valid, the table here. As long as when you put the adjacent cell, they are really adjacent to each other. Okay? Differ by 1 liter. This is very important. Otherwise, Kemet won't work. Okay. You only can circle the block that are adjacent. Okay. It's on how to construct the cell. Second. Yeah, so for 6A, for example, this case here, you have a mean term with 3 literal, okay, and then you have one block of size 2. So a block of size 2 will reduce your mean term by 1 literal. Okay, so 3 literal mean term get simplified to 2 literal. And then if you have larger block, okay, for example, block of size 4 cells, will reduce your mean term of 3 literal to 1 literal. Okay, so you can also work out, try to convince yourself why this is true. Okay, use algebra. So how to use algebra? So you can combine. Which one? Let's see. You can combine. You can combine the first 2 terms first, and then combine the last 2 terms. So where you get x times z y z bar plus y bar z bar plus x bar y z bar plus y bar z bar. Okay, and then you can see that you can combine again, right? So you can combine x plus x bar times y z bar plus y bar z bar. Okay, and then you get 1 times y z bar plus y bar z bar, and then you do the same. Okay, so yeah. Okay. Then after that, you just need to use your experience. Is it correct to say on this? Uh, so yeah, yeah. Yeah, it's not enough to do just know algebra. You need to know how to see from Kemet. Okay, you need to know how to see from Kemet. Okay, C is 0. Okay. This one, right? This one is not sum of sum of product yet. So you need to expand it. But when you expand it, you realize that this thing is actually 0 because you have the z bar multiplied together to get 0. So every term you have this 0 because the literal commute. So x bar times x, z times z bar, y times y bar, z bar, z times z bar. So everything is 0. 0 plus 0 plus 0. Okay. Okay. Yeah. So this one here, 12.4.8 asks you to construct a K-map. Okay. And then asks you to find what are the implicant, prime implicants, and essential prime implicants. Okay. So okay, so actually every cell of one is an implicant. Okay, implicants is just what's the definition of implicant? Okay, not from the box or not. What's the implicant? English. Exam is in English, by the way. Please learn English. Hmm. What's implicant? Hmm. Product of bilaterals and then corresponding to a block of all ones. Okay, so block of all ones. Okay, so any block can be a literal. This block have to be product of the power of 2. Okay, so in particular, 1 times 1 is a block. Okay, so any block, okay, the product of literal correspond to any block of 1. Okay, for example, this block or block of 2. Okay, in this case, the maximum is block of 2. So every block of 1, the product correspond to every block of 1 is an implicant. Make sense? I repeat. Okay, so okay, let me write down the definition. So of literals correspond to a block. One is called the implicant. Okay. So as long as you have a block of 1, and then you read out the mean term that correspond to the block of 1, then it is an implicant. Sense. So for example, what's the mean term correspond to this block here that I draw? SYZ bar. Okay. So this is a SYZ bar is a implicant. But XY bar Z bar is not an implicant because there's no 1 here. And you cannot draw a block here. Okay, makes sense? Okay. For example, you draw a block here. Okay. What's the mean term correspond to this block here? Huh? What? What's the mean term correspond to this block here? XY. Okay, XY. So XY is an implicant in this example. But X bar, Y bar is not. There's no one here. And you cannot draw a block. Make sense? Okay. As long as there's one and then you can draw a block there, then you can say the implicant. Make sense? Okay. Okay. Any other question or not? This is your final chance to ask question. After this class, I also won't ask you to ask question anymore. Okay. Your last chance today. Okay. Next one is what? Prime implicant. Okay. So what's the definition of prime implicant? What's the definition of prime implicant? Huh? Anyone got the note or not? If the block is not contained in the larger block. Okay. So you can see that actually these three block here is not contain a larger block. Okay. So what do you mean by containing larger block? For example, you have something like this. Okay. So you can see that X, Y, Z bar is contained in the block of 1. Okay. So X bar, Y, Z bar is not a prime implicant. Okay. Make sense? Yeah. How about essential prime? Okay. Essential prime, what's the definition? What's essential prime definition? Huh? The largest block of one that covering one in the map, I think. With least number. What's the word I use in the no? Actually, no. Yeah. Okay. So if it is essential, it's the only largest possible block of one covering a one in a K-map. So for example, these three are prime. Okay, because you can see that the one they cover, they are the only one that cover some of the one. Okay, what do I mean by that? So for example, if you look at the green one, okay, so there's one that's not covered by the other block. For example, this one. Okay, so this is the largest block of one that cover the one in the camera. One in the camera. Okay. For example, this one, the pink purple one, okay, this is also an essential prime implicant because it cover a one is the largest possible that cover one. For example, this one here. Okay. Although there's an overlap here. Okay. But this overlap is only occurring for one of the one. Okay. It still cover one that's not covered by the other block. Okay. So let's say let's say we have another block. Okay. If we have this kind of block here, okay, then the purple block is not essential anymore because both the one covered by the purple block is covered by the blue one and the green one. Okay, so it's not essential anymore. So in simplification of circuit, we are interested in the essential one because essential one will cover all the midterm. Make sense? You can see that. Let me remove. So you can see that these three essential prime, right? These three essential prime cover all the one in the circuit. Okay. So we are looking for the essential prime implicant every time. Make sense? Okay. Every time we are looking for essential prime implicant. Example to see. And let me move down to other one. Okay, this one. Okay. So you can see that. Okay. Let's see, we want to reduce these 5 terms. Okay. Reduce these 5 terms. So you can see that there's some guy is not essential. So this block here is not essential. Okay, because both one is covered by different implicant. Yeah. And then this one is also not essential. Okay, because this 2 1 is covered by other block. Okay. So which one to include now? So which one you need to include? Okay. So first we need to include all the essential first. Okay. And then you realize that there's one that's left out. Okay. So there are 2 choices here. You can pick this one, non-essential one, or you can pick this non-essential one. Okay. If you pick both of them, no problem, but you are not simplifying because you're not finding the least number of min terms to represent the function. Okay. So you only need to pick 1, 2, and then one of them, 3, to represent this function. If you pick 4, all the 4, then it will be too many. So the goal is to find the least number of blocks to cover the function. Make sense? Any question? No? Okay. Okay. So in the exam, I don't want to see this one, block of 3. I don't want you to draw something like this. Okay. Don't draw this. If you can draw this, you cannot write this. Okay, maybe you get some mark. If you draw something like this, sure no mark. Yeah, don't draw like this one. Okay. You cannot combine 3 terms one. Part product of power of 2. Okay. This one, you see this one. Okay. 6 term. Okay. You can see that there's a lot of non-essential prime implicant here. Okay. So, these are non-essential. So which one to pick? All of them are non-essential, you see? If you look at this, the 2 1s are covered by different blocks. If you look at this, the 2 1s is covered by different blocks. Okay, so there are no essential prime here. So how to pick? Simply pick. As long as you cover all one. Okay, let's say you pick one. Okay, which one you want to pick? Let's pick one. Which one? Maybe you can say about the mean term and then we will know which block you are talking about. XZ. Okay, XZ is where? XZ is this one. Okay. So after you picking this, okay, you left with 1, 2, 3, 4, 4, 1. So how you pick another block? X, XY. So this one, XY. Okay. And then you need to pick this one, right? Okay. So you get 1, 2, 3 terms. Okay. And then you're not sure whether you got the least number or not. You need to check. Can you do it with 2 terms? Is it possible or not? Okay, in this case, it's no. But in reality, you need to check. Okay. You cannot say, I cover it. I think this is the last one. Maybe you can cover more. Okay. So in principle, you need to check whether you have covered all the one with the least number of block. Okay. How do you check? Uh, how do you check? You just need to try. Try and error. Try and error, I think. Okay. So in principle, you need to check whether you have used the least number. Any question? Question? Okay, 4.14 is the repeat one. B repeat one. Repeat. Or repeat. This one. Okay, this one, right? This one maybe I'm a bit confused from last time. In particular on how to draw this table here. I still want to try again. Okay, let's try this again. So this is the Queen McCluskey method. Okay. So what you do is you list your min term from your function. Okay. And then you replace your literal with 1 or 0, depending on you use the complement or you use the variable. Okay. You use the variable or you use the complement of the variable. Okay. If it is x, you put 1. X bar, you put 0. Okay. And then follow the order. Okay. X, Y, Z. Okay. So you cannot like suddenly change the order, become like this. Okay. Then the big string wouldn't work. It's a different big string. Okay. And then the next one is you need to consider all the possibility of simplifying the product. Okay. So you need to check 1 with all of these, 2 with all of these, 3 with all of these, whether they are differ by 1 literal or not. For example, maybe we look at larger example, then more things to see. Okay, let's look at this example then. Okay, so for example, you need to check 1 can be simplified with 2 or not. Okay, 1 can be simplified with 3 or not, and then so on. See whether they are differ in 1 literal or not. Okay, so for example, 1 and 2 differ in 1 literal. Okay, you can combine. 1 and 3 differ by 1 literal. Also, you can combine because y is different. 1 and 4 differ by 2 literal. So you cannot combine. 1 and 4 cannot combine. Okay, and then you keep checking. Okay, after you checking 1 with all of these, then you check 2 with the rest. You need to exhaust the list. Exhaust the list that you can simplify. Make sense? All possible you need to write down. Okay, so how to run through all these possibility? So you check 1 with all the rest, and then 2 with all the rest, 3 with all the rest, and then 4 with all the rest. Okay, then you can run through all the possibilities. Okay, and then after you simplified it, for example, 1 and 2 simplified, z and z bar become 1. Okay, so z disappear. So you put a dash. Make sense? Okay. And then you do the same for the rest. And then you keep doing this for step 2. For example, who and who are differ by 1 liter. For example, 1 and 6 and differ by 1 liter. So they can combine. So 1, 2, 3, 4 from here get combined to x. Okay. So you do it for everyone as well. Okay. And then you can realize that you can get x, z, and y bar. Okay. Similarly, if you simplify, if you cancel the literal, you put a dash. Make sense? sense? Okay. So yeah, this part, come to next part. I didn't explain well how to put this cross here, right? This cross is actually referring to this number here. Okay. So for example, if x is coming from 1, 2, 3, 4, you need to put a dash from 1, 2, 3, 4. So if z is coming from 1, 3, 5, 6, you need to put a cross at 1, 3, 5, 6 because it use 1, 3, 1, 3, 5, 6 to build z. Okay. So these four terms combine into z. Okay. Similarly for y bar, 3, 4, 6, 7, 3, 4, 6, 7 combine to become y bar. Okay. And then the same story, you need to find the essential prime implicant. Okay. You need to find enough implicants to cover your function. Okay. So if you pick the first one, so for example, if you pick the first one, you will cover the first four terms. Okay. So you still need to cover the last three terms. Okay. So if you pick the second one, you will cover the last fifth and sixth term. Then you need to include the last one to cover all the terms. Okay, that's how you pick. Do you see the similarity between CAMAP and this method here? You see the similarity? You should see it. Okay, there's some similarity here. Just a different way to write it down. Any question? Any question? Okay, if you have question later, we can repeat again. Maybe now we breakfast and then we come back with summary. You think properly. If you still don't know, make sure you ask in the next hour. Okay, we still got 2 more hours. Okay, we take a break, 5:22, and then we come back. Yeah. Oh, yeah. Oh, yeah. Just now. This one. This one. Okay. Down. Uh-huh. This one to see. Okay. Mm.
3、4，
嗯
哦，所以3个我要 combine，因为它会 cover 完全部。
对，
对，这样子我看这一个，然后我要写出那一个 midterm sum of product 最 minimize 的最终那个结果。
要来
啊，
写在这边，来，
然后我要讲看这个图哦，说它选怎么出来。
来这边，
啊，有这些。
呀，
然后这是 Y 吧？
呀，
这个
嗯哼，
这些东西都会变成 X 啊，所以我就写成一个 X。
对，
然后像这些东西，然后我就写
对，
再加 Y 吧。
对，
所以就是我的最终答案就是 X 加 Z 加 Y 吧。
对，对，这个要跟他们讲声，不然等下他们又做那边又停。
会不会有出现那种可能性哦？你像这个是 Y 在前面，然后 X 吧这
可以啊，就是讲 就要排它，不然的
可是
话你就不
刚才讲不
consistent 了。
能排，
可以排啊，它
可以排
commit 啊，commit 我讲你不可以那样子写，
哦，
可以排啊。
你不会写那个一跟零，你换写成一跟
对啊，
零是吗？
它就代表不一样的东西，就不是 consistent 啊。这
对，
对
它就不能这样加，
对，
可以，应该
没有错。OK，嗯
它不到完全可
嗯，
是你用完 XYZ，
呀
你用完全部这些 component 就不用看其他的
对，
啊，就一看到用完全部了就不用看其他的。
因为又没有解释到那个，因为这些用到我们就叫做
它会
不
重复，
prime implicant 了嘛，对不对？
它会重复。
它不是 prime implicant 了，所以我们不要用不 prime 的 implicant。对，
就看这边的 right，1、2、3、4、5、6、7用到就可以了。
嗯，你是说你只看这个，你不做这个是吗？
对，
嗯
我是讲，因为其他的也是可以配啊，这样1、5跟
，Yeah
6，
Yeah，一样哦，它
对，
就
就是是一样，
可以这个
还
汤吧，
是一样，
嗯，
所以不用做了。
代表一样的东西，就不用再重复啊，
呀，是要看它一样才不做，还是看到用完全部就不用做？
看到一样就不用，
对，还要看完全部是吗
要，等下你看漏掉了
？OK，
呀，因为它呀，嗯。可能它比较大的 example，13可以跟78跟10多的合在一起啊，不一定。嗯，那我们的13，对呀，哎，这个题目想这种包括打击这个，明白？对呀，是这个啊。
但是我
什么问题？
这个只有一个圈，这个不是那种。
哦，对，因为这个两个是隔壁 adjacent，所以这一个 term 啊不是 prime implicant，可以理解吗？其实它还有一个更大的 block，它就是它可以把这一个和这个连在一起。
一定要这么放。
因为你要最大最少，用最大和最少的 block 来
但是你那么
保护，
画也是3种，我那么画也是3种。
但是你不是最大的，
哦，就是你每个 block
也要是最大，要最大最少呀。因为呀，因为你这一个 implicant 不是一个 prime，是 prime，它不是 prime，
对，
嗯，因为它 contain 在一个更大的，
那这个
嗯，对，
呃，那这个我也把这它专门把一个 prime instance，
是
它这种，但是它不是，它只是一个这个一被这个覆盖，然后这个一被这个覆盖
对，
也算吗？
算
也算
它只是
在
不 essential 了。
但是它也包含在更大的 block 里头。
它没有包含在更大的 block，只是它的包含在不同的 block，懂我意思吗？
哦，
如果它不 prime 的话，它需要有一个4×1或者2×2的 block 来包住它，懂我意思吗？需要整个被一个包住，这个才叫不 prime
这个被
啊。
不叫 prime，被包住不是才叫 prime。
哪一个？OK，你看啊这个里面呢就不 prime，外面的 prime。
快把自己它到底算不算 prime？
算，知道为什么啊？
因为它没有包含，它是被两个包，不是被一个包。这样，
definition 说它是 the largest block of one that cover the one，对，它是一个最大的 block cover 这两个
哦，那也就是如果有一个这样包含四个，那就
所以就是我画的
所以它就不是，所以被两，
对对对对，但如果它是分开被包的话，就是说
它不算一个，
它不 essential
算
它不它
不是 prime，
它是
这不
prime，
prime
但是它不
被
essential
essential，
因为它的 E 也有被
这里的所有的不是都是 prime，
这里边所有的都 prime 对，
所有都 implicant，所有都 implicant，
因为都 implicant，所以都 prime，但是不所有是 essential
这个意思。
那个是 essential，因为它有一个 E 是不被其他的 block 绑住，
这个也是
也是那个意思。
那这样一个小的算是一个 implicant，
算，只要它是 block of one，
它只要是一就是
它只要 block of one 就可以。block of one 的 block 的意思要 power of two，你不要 block，不要3乘1的 block，没有这样的 block。1乘1还可以吗？2乘2零。那又解释到我去。
不是，其实我想问，就是拿4个嘛，是我们俩就好像这个跟这个可以拿到这个，
没有错，
这个跟这个可以拿到这个，
没有错。
就是说他们其实如果他们每两个对比，他们 same 它的 result same 的话，就可以达到这个嘛，对吧？
所以呢，
我们有没有可能出现 step 3？
有可能，
也是有可能，
有可能，
哇
它可能
不一定是 step
很
3。
大的时候，更大的时候，
就是如果我们出发如果我们有就是这两个可以合成一个两个，然后合成另外一个之后，他们两个又可以合成了之后，我们就有 step 3了。
对，可能有一个零零，零在零就可以了。
所以我们不一定是固定的啊。
做到不能。
这样子。
Okay. Let's start the summary. Okay. Let's start the summary. Then I'll try to summarize the thing again. I'll try again. I think I missed out something. Okay, so let's start the summary after midterm. So what's the topic? What's the topic after midterm? Who still remember? Yes, counting. Okay. So counting, you learn product rule. Okay. Sum rule. And what rule? What else? Inclusion, exclusion. Pigeonhole. Actually, I want to put pigeonhole in exam, but rush. And when I teach this, I will add. Next semester. Next time, I don't know when's the next time I teach this. Next time, must put pigeonhole. And then we have permutation and combination. Okay, this one really important. So in permutation and combination, what we have learned. Okay, the notation, if can try to standardize to this notation. Okay. If I suddenly mark wrong, then you cannot argue. I don't know how, because if you want to check the exam paper, you need to pair something like that. Then maybe they won't approve. So make sure you write properly in the exam. it's very hard to check the paper because you need to pair, you need to get approved. I heard normally you won't get approved one, but I don't know the reason. Okay. And then also the binomial theorem. Okay, binomial theorem. You need to know how to use. Remember the binomial theorem? Yeah, how to extend the power of two variable. Okay, make sure you know how to use it. I think I also put inside the review question. Okay, product rules. Okay, go through the quiz, the pattern. Make sure you really know when to use product rule. Okay, product rule is something like F1 times M. Right. How do I write it? Yeah. So sum rule is something like and then product. Okay. Okay. Make sure you go over the quiz. And then there's one more thing I need to remind you again. So in my exam, you must write what law you use, what rule you use. Okay. These sum rules or what product rules. This rule with name you need to use. I need to remember. If there's no name one, for example, the planner, then never mind. You just say by corollary or by theorem. But if there's a name, you have to know the name. Okay. And also, if you see the question is like yes or no, and it is more than 1 mark, then you need to explain. Okay, don't just say no, yes, no. Okay, then. Okay. More than 1 mark, you need to say. Okay, I think counting is more or less like this. Counting quite fast, we finish within 1 lecture. Next one is relation. Yeah, this one is longer. Okay. So relation, we have what? Equivalence relation. Okay. Equivalence relation. Okay. So you learn what is reflexive. Okay. First, you learn what is relation. Okay. Definition of relation. Okay. Relation, we don't need to care whether we don't need to care about the what's the connection between two elements. We just need to produce a subset of Cartesian product. Okay. So relation is a subset. Remember, it's a subset. Okay. Subset of what? Of S cross. Okay. If I say equivalence relation of X. Okay. Subset. Subset is enough. Okay. Subset. Second, we talk about reflexive. Symmetry. Make sure you know what this means. Next, we change to partial ordering. Okay. Where we swap the symmetric with anti-symmetric. Okay, so we replace symmetric with anti-symmetric here. Okay, reflexive, anti-symmetric, and yeah. Okay, and then the next one is okay, and then all sort of order. I'll try to write it. Okay, so maybe I write down totally order, reordering, square ordering. Yeah, Yeah, make sure you know what this word means and then how to check examples. Okay. I wanted to play hard question in this topic here, but I didn't. So make sure you know the examples, okay? Okay. Okay, one thing very important here. One thing very important here. So divisibility, I think in my quiz I forget to put Z plus. Okay. In my final, I think I also forget to put. So when you answer the question on divisibility on Z, make sure you know that it's Z bar, Z plus. Okay, because we only define divisibility on positive integer. Maybe if not everyone is here, I will make a post as well. So in the exam, you don't ask me again, there's a typo there. I think it's a bit late to change. Okay. So whenever you see divisibility on Z, right? I write something like this. Okay. This one is actually mean this one is wrong. Actually mean Z plus only. Okay. Z plus. Okay. Understand or not? Yeah. So it's a typo. Even in my quiz, I also have this typo. But I think most of you, not most of you, some of you know it. Yeah. Actually, in the class I mentioned about it, but I have this typo. Okay. So this one is wrong. Whenever I talk about divisibility of Z, it's actually on Z plus positive integer. Okay. So we don't discuss like -3 divide 3. So we don't discuss this. Okay. We don't discuss this. Make sense? Okay. So relation is this. Oh, I forgot to mention. Yeah. So here we can construct a Hessel diagram. Remember the quiz we have Hessel diagram. So you need to know how to construct Hessel diagram. So you can see that this is special to partial ordering. Equivalence relation, you cannot draw diagram. But partial ordering, you can draw Hessel diagram. And then from here, we enter graph and trees. Okay. So from here, we enter the graph and trees. Okay? Okay or not? Okay? The last thing we learn in this topic, Hessel diagram. And then the next thing, graphs and trees. Vertex edge. Okay? Anything you want to ask about relation or not? You can ask me whether this one is important or not. Open for you to huh? Equivalent class. Equivalent class. Okay, let me list it down first. Equivalent class. Not too important. Yeah, not too important. Equivalent class. But I forget I got 2 questions on that or not, but not very important. Yeah. I forgot got or not, but not too important. Yeah, even got only maybe 1 short question. But I forgot whether I got that question or not. Equivalent classes. seriously, I forgot seriously. Seriously. Okay. Okay. Equivalent class. Anything you want to ask about this relation? Yeah. This one quite a big topic. Yeah. Okay. Make sure you go through the examples. Okay, examples tutorial. Okay, this time if you can finish all the tutorial, I think I can guarantee 80 marks. 80 marks. 80. So make sure all single tutorial you go through, include the review question. Then you can get 80 marks. Last time only 670. Huh? 670. Different. Hessel diagram is what? Offset. There will be question on equivalent classes and equivalence relation as well. Yeah, both will have question. Both will have question. Both will. You will also need to yeah. Both will have question. Okay. Both will have question, right? Okay. Both will have question. Okay, next part we enter the graph and trees. Okay. This part I would say there's a lot of like short question. It's like the quiz question like that. There's a lot of short question. And it's like a quiz question. So in graph and tree, what do we learn? What have we learned? What have we learned? Part type by part type, huh? Okay, maybe we straight away jump into those topics then. Maybe we don't talk about okay. Let me write down. So we discussed about the locality properties. Okay. So for example, the degree of vertex, right? Degree of vertex, and then what else? Neighbor, something like that. Neighborhood of vertex. Okay, and then some matrices, incident matrix, adjacency matrix, adjacency matrix, incident matrix, incident. Yeah. Okay. Yeah, this one. And then you have a theorem, right? Here there's a theorem, the handshaking theorem to link the number of edge and the degree together. Handshaking theorem. Okay. Okay. And then next, then we go into the bipartite. Okay. Bipartite. Okay, so you how to check bipartite? You check whether the chromatic color is 2 or not. I still see that a lot of you don't know how to find the chromatic color. I see that in the quiz, I don't know, someone put 8 for chromatic color. I don't know how you get the 8. Now, what's the chromatic color? Okay. Yeah, you need to know how to determine something is bipartite. Okay. And then what's the next one? Next one is the 7 bridge problem. Is it? Yeah. So you got the Euler path, Euler circuit. Okay, and then also Hamilton path, Hamilton circuit. Hamilton circuit. Okay. So among these 4, only 2 of them have a definite condition. So only these 2 have a condition on them. Okay. So I mean condition to find them. So Euler path you need to have exactly 2 odd degree vertex. Okay. Euler circuit you have to have all even degree. Okay. So with this condition here, I can quickly check your answer one. If your path don't start with or end with odd degree, your path sure wrong. I don't need to check whether how you going through. Okay. So Euler path must use these 2 odd degree vertex to be. So when I mark your quiz, right, I just need to see what's your starting point. If your starting point, degree vertex, sure wrong. Okay. And how to determine whether a graph have Euler circuit or not? you need to make sure all the vertices even degree. Okay. For vertex. Okay. So you no need go and try whether I can draw Euler circuit or not. No need. Just go and count the degree. Okay. If you try order, then you lose time. Only 2 hours only. Okay. Don't try and draw, right? Use this condition to check. So these are theorem. Okay. So only these two you need to try. There's no quick answer. Sometimes has quick answer, but you need to argue. So these two are harder. Okay. What's after this? Okay, after this is the planar, right? Is it the planar? Is the planar? Okay. The planar. Okay, there's some. Okay. I'm not sure you remember or not. There's some corollary on this, or called the Dirac or the Orr theorem. To determine for Hamilton circuit. Also checking the degree, but a bit tedious. I think I don't have this question, but to be safe, you just read first. I think I don't have. A bit tedious. Normally, if we come up with the exam, right, we won't put tedious question. Right? We will put question that when you read, and then you will know what the answer. Okay. Next is a planar graph. Okay. A lot of these are you guys do in the quiz. You just see that hey, there's a edge crossing and it's not planar. Actually, you can move the point around. Okay, find the isomorphic graph that have no edge crossing. Okay, don't straight away see there's a edge crossing that is a non-planar. Actually, you can move the vertex around or move the edge around as long as they are isomorphic. Okay, planar. Okay, planar is more interesting. So there are like Euler formula here. What else you have? You have yeah, homeomorphic, correct. So we have let me see if there's here again. I think there are 3 corollaries here. Okay. 3 corollaries. Make sure you know how to use this corollary. Don't simply use. You check that it satisfies the inequality, then it is planar. This is the wrong direction for the corollary. The corollary is like if G is planar, then something happened. Okay. Not something happened, then it is planar. Okay, it's not used like that. Understand? Understand? Then some inequality is true. Okay. So the inequality is true when you know if something is planar. If you don't know it is planar or not, whether it's true. Okay. So it's not the inequality true and then it is planar. This is the wrong direction. Okay. Direction is you know it is planar, then the inequality is true. Okay. What you can use is if the inequality is not true, then it is not planar, which is the contrapositive of this statement. Okay. So don't use it wrongly. Okay. Okay. Okay, then the next part is the homeomorphic one. Homeomorphic graph. And then what else? And then the Kurosky theorem. Kurosky theorem. Okay. And then don't simply use this Kurosky theorem. Make sure you found the K5 of K33. Okay. Don't simply guess. You have to find the K5 or K33 as your subgraph. Okay. Okay, graph and tree is slightly longer because we take like 4 weeks to finish it. Okay, so next is what? Graph coloring. Yes, graph coloring. Make sure you really know how to color the graph. Color. Okay. Line. Say something. Okay, I should say something here. Okay, this question definitely got. Okay. Chromatic color definitely got. So how you should answer that question? So first, if you say that it is equal to K, okay, then you need to argue why chromatic color is less than equal to K and chromatic color Y is greater or equal to K. Okay. So why is it less than equal to K? So because you can use K colors to color the graph. Okay. So first you need to produce a graph coloring that contains K color. Okay. Because chromatic color is the least number, so it must be less than or equal to K. Okay. And then why is it greater or equal to K? Depends. Okay. Depends on the K. Okay. So usually it's because contains a complete graph of the bad notation. Maybe I put M here. This one is usually, not always, usually because contain a complete graph of Km. Okay. So you have a complete graph of Km, you need to have at least M color, different color to color. Make sense? For example, if you have a triangle, because they are connected, you need to use different color. Okay. So if I square, okay, you need to use at least 4 color. Okay. Usually, not always. I'm not promising anything. I just give you an idea. Okay? Idea. Not promising. I forget my question already. But usually, yeah. Okay. But this one is always true. This one is always true. Okay. If you can use K color to color your graph, your chromatic color must be less than or equal to K. Because chromatic color is a least number, but you already use K color to color it. Okay. So your least number must be less than or equal to that number. Get it? Get it? Okay. Okay. Any question? Want to ask? No, have a question. I'll give you a chance. Okay. So we only spend time with graph only. So next one is tree. Okay, trees. Trees. Trees, a lot of algorithm you need to know. Yeah, this algorithm you need to know will be in the exam. So tree, we have the labeling of vertex. Right. We have the what? Ancestor, descendant, parent, what else? Children, sibling, internal vertexes, and then all these terminology. Make sure you know how to address the vertex, subtree, rooted subtree. Okay, because those are important for the tree traversal. Okay, so tree traversal we have what? Okay, this one is on the ordered rooted tree. Right. So what do we have here? We have the universal system, address system. Yeah, these are, and then pre-ordered traversal. These are all very important. Remind you. Order traversal. You will need to perform this and post order traversal. Okay. Actually, universal, right, is the same as pre-order. You can go back and check. Actually, these two will give you the same ordering. Okay. And then the next part is the spanning tree. So spanning tree have there's a weighted version and not weighted version, right? So one is the non-weighted. It's a weighted. Okay. So non-weighted one, we have depth first search and the breadth first search. And then weighted, we have what? It's called the prime algorithm, and another one is Kuska. I forgot got this question or not. Okay. So make sure you learn a bit. Okay, I think that's all for graph and trees. Any question on graph and trees? Any section you don't like, you want to ask whether it's in the exam. Hessel diagram. Hessel diagram. Oh, yeah, okay. That Hessel diagram. Okay, Hessel diagram, we have the GLD, LUB, upper bound, lower bound, and then what else? What else? Maxima element, minimal element. Yeah, I think got. Yeah, I think got. General advice is quiz question are very important. This is the general advice. Quiz. Yeah. So you have 3, 4, 5, right? After midterm. So these 3 quizzes very important. Huh? Proof question, huh? Only on checking this definition, not the not twisting question. Okay. Checking definition and prove that something is transitive, reflexive, something like that, just like that. Okay, no definition question. Nothing more other than that. Trees. Okay, trees. Standing set. Okay, after trees, then we will end with the Boolean algebra. Okay, I can quite straightforward tell you that we will focus on the function part. Okay. So we have the abstract definition. Okay, we focus. I think there's only one question on this topic. Function, okay, Boolean function, and then minimization of Boolean function. Okay, which is the K-map. K-map is very important. K-map very important. The reason why I put the what the name? I forgot already. McCluskey and McQueen. Oh, Queen and McCluskey. Huh? Okay, just put QM. Huh? QM algorithm. Okay, so QM algorithm. Here actually both of these, right? You care about, I just talk about the general principle of these two, right? So you can go back and read again. So the general principle is to find all prime implicant, okay? So there's a good reason why we call it a prime implicant. Because every number can be read out as product of primes, okay? So you need to use these prime implicants to beat your function. Yeah, so you need to find all the prime implicants. Okay. So this topic here, the important one will be K-map, Boolean function. Truth table maybe appear again. Okay. Truth table appear as a Boolean function. Hey, I take this now, I forget to pass. Oh, I already passed. Okay. I forgot. This one Wednesday. Any question? Any question? Huh? What's again? Maybe no. Not during okay. Too tedious. Too much work. Huh? Which one? Which one is not important? Which one? Which one? Oh, you ask me which one is not too important. Uh, I already said just now. Huh? Um, you ask, you ask. I want to say. Like sometimes I say this one is important, sometimes I say that one is not important. I want to make two. I think spanning tree we don't have. But you just read through, but I think don't have spanning tree. I don't promise anything. Don't test my word. If I say important, then you need to extra focus. If I say not important, you just understand, read it. Okay? If you don't read, then come out, don't blame me. Okay. Important, you spend extra focus. Okay. Any question? So far not. Home, I think no. I think that one pretty confirmed. I think. Hmm? Hmm. Yeah, I got it. Any more questions? So if you finish all the tutorial questions, you will have at least 80. Any more questions? Huh? Okay, if not, let's take another break. If you still have 1 more hour, can ask me right? Whether something is in the exam or some misconception. 6:10, we come back for quiz. Okay. In the meantime, one by one, you can come collect your quiz.
我哪里？我本来你的意思。哎呀！你那个，你那个，你那个。我老婆年到，好吗？哦，不这样，因为你可以试一下，你可以试一个东西，你看啊，你做一个那个 truth table，这个做一个，这个做一个，他们的不一样的，可以这样做。这 truth table 给他。就是这样，就是然后你看到他们2个 X 包60%。如果他有20，这个换的话会到2个出牌的，你看到这个出牌的它是一样的。没有，他在这里啊。我的弄别的，这他妈都是你的。然后你有没有别的弄别的？那有。啊，对，我知道这个里。可以。你不会拍条片啊？我还是不有几个你们这样，来，经典好高度。 整个
改不了你的你的任务。
哦呀，哦，
味道有
哎呀，这么离，哎呀，
等等也就是那个小地方，那个小就是我其实单有，但是我也没有说，我也没有带你说我的，所以就是如果我就去玩，下就到到。没有特别，不要特别。好了，OK。
Your friends still haven't come.
she don't.
They don't come. Okay. 什么在这？呀
然后我们打过40
？Yes.
是讲40 over 100，还有40 over 100，但是我今天听老师讲要拿60 over，
没有，40。你老师是谁？我不是你老师吗？
没有别的科的，
哦，不要老师，没有，我们科是40，
就是讲
40，然后后面是55，55。
啊，总共要拿55，就是拿，所以就是讲continuous上面40 over 100，然后 final exam 40 over 100。哦，
这是我。
OK 哦，有信心吗？哦，是你啊。OK。是好看，有好些。你是的哈？
对，
哦，为什么转过来？
对，OK。
哦，还要懂。
对，是我的放回去再给你了。对，
你呢？啊？
你们带他
有
应该还有参在分，没有啦。
不是？没有到很低。
有没有可能这个可以给我一上面写它的颜色数？
不可以，
不可以，
什么意思？我就
应该给他注个中文，
就是要抓一下这人，就是要抓这个。
还有这个写公式没有？
没有啊，又不是这里写。
那不就是这个公式里的？
是2啊，你写2就好，写这么多干嘛？
老师可以让有20，
可以，
不可以，
公式可以
可以。
来的。
那你明白？他明白一个答案，差不多100。你明白就应该放个2就好。
这个不行吗？这里写了颜色
不行，
我换
然后
颜色。
让你记住一辈子。
为什么？
写个6，我也不知道你6从哪里来嘛。
我不知道这个单词什么意思。
OK， 你6从哪里来解释给我听看。
我以为是问面数。我当时有6个面。
那你也不算有看
啊？我这里把平面图画了。
好，
你干嘛把颜色都放过去了 ？Blue red。
我把它画在这里，我这个可以。
啊，
多一个点就可以。
啊，对，多一个点就
然后
可以。
我觉得是对的。
看一下啊。
我想啊，
写完人，然后就把这个二写到后面。
因为我那时候看好像多了一条线。
哦，12到18是没有的，我就把我的挺，我的那10里来的是太期待。
注意一下，也不对。为什么你不把你的 panel 图画出来呢？
忘记了
啊？
忘记了。对，这个也是忘记它那个什么意思了，我就不随乱写了一个。
所以你8是从哪来？也是面。
没有，就是
8是什么？
随便一个数了，随
随便一个数。
谁也不够了。这个也没有吗？都是就是
有。
还这个就除了写一个 r 等于1减 v 加2，我的3个定理都写上去了。
没有，我要2吧。
看它有
我要数字2吧。
那这个也不行，就是我用的是2来推倒推，就是用这个定理2来倒推它不是平面。
我不知道是你推不出了，刚才说没有东西是推得出一个东西是平面的，那个只能够推出它不平面嘛。3个 core 都推不出它到底是不是平面。
是的，还有我在写。
你看我现在还是等一下？现在我要讨论了，我还没有讨论，我讨论 OK 干嘛？
英文我都会。
这是什么意思？
为什么扣1分？
为什么扣1分啊？
为什么扣1分？
啊，我不。哦，你的 path 好像有问题啊！你的 path 走一走看 ，E H F B A C D 呀，你没有走掉，你没有走这2条，哇，你漏走了2条。
哦，
呀，其他全部都是。对，
这个它为什么只有1分？我把它路径给放在这里。
对，你的路径应该怎么读啊？
就是这边有1和2。
哦，OK，这是我读漏掉1、2。
请问那3个没有解答。
9、10、11，对，好，
这个是可以的。
太不对，对，但是最好我们不是有学过怎么写的路径
啊，也可以那样写。
或者你也可以在它旁边画那条线哦，画一个不断的那个路径。
那这个是能压力，
可以给你
行，加1分吗？
啊，
这道题不是4分。
4分你还没有解决这个 Euler circuit
然后我有说
哪里？
我有说它是这个，
但是你没有说有没有这个
一个惨痛的教训。
这2个不同。
我默认它是这个的话，就不是这一个。
因
为它是它的话，
我失误。
是要写，
要写，
要写。
那不应该就扣1分，那不应该加2分。你看我还有这么多证没有。
OK，等下，我讨论完。OK，你记住一下，我来讲。
也是，我也有标题。
哦，你也是标？
对，就1、2、3、4、5，就是5、6、7、8、9、10、11、12。在这。
1、2、3、4、5、6，
然后7、
8、9、10。OK，
是的。
可以。等下我加1分。
还有是
然后讨论完啊。
写了答案，然后我想着我就写完整一点，我除了重写，
你现在
然后我就忘了，我本来写了答案，这个太愚蠢了，算了。
OK，
我写了，然后划掉，我也写一个。
我也没有看到2在那边。
对，我想我写个整，然后这个2不写。
OK。
对，
因为你画什么星星在这里？
我写了个，我写一个整的句子。
可以。
待会儿再来。
待会儿啊，然后我直接加了。跟我讨论完这
个2分。我讲是有个报告
啊，对，这个2分，对，因为要讨论
我讲是这个，
要讨论有还是没有？
没有写就是没有。
啊，要写，
这点纸啊？
啊，要写，
一定要写
啊，其他人也是。对。OK，来看一下，我讨论一下再来。哦，你啊，为什么啊？这里有了，你还要去找另外一个？ 就做多余的工作，就是
这个不了。这个哦，你要讨论，OK。
no problem. Okay, so let's discuss. This quiz have a big significance in your exam. Right? So exam will be similar to this. Okay, so everyone can see. Okay, so maybe okay. 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 Yeah. Two things to remind you here. So remember, divisibility. I think I has a typo in my exam. So make sure when you see this, automatically change it to this positive integer. Second part is the Euler path. Okay. Make sure you draw path with non-splitting path. Okay. So for example, don't draw something like this. Okay. Because I don't know whether I want to go here or I want to go here. Okay. Or you just label your vertex. Okay. And then you write out the vertex. Okay. Yeah. Bracket. Bracket. Don't just draw arrow because you see this. If I go to here, I need to go here or I need to go here. Right? Don't ask me to guess. Or you can draw the path line. This and this also can. So make sure you have a clear answer telling people what's the path is. Okay? Yeah, these two things you need to take note. Okay, so first task is explain why the divisibility on the positive integer is anti-symmetric. So you just need to write as for every AB, A divide B and B divide A equal to B. Okay, so a lot of you say that if A divide B, B don't divide A. Okay, true for most integer, but if A equals to B, then A divide B, B also divide A. Okay, so this is only happen when A equals to B. Okay, so there is situation where A divide B and B divide A, but A have to be equal to B. Okay, some of you say because 1 divide 3, but 3 not divide 1, so it is false, and then recursively true, and then false, not true. Okay, so if A divide B, B divide A, then A must be B. Okay, make sense? Okay. Okay, but one mark only. Next one is the Hessel diagram here. Okay, actually I forgot one thing here. Actually, I need to put a hint easier for the calculation. The hint that I want to put here is consider the what's that? What theorem is that? What's the theorem that says you can break number into a product of primes? The theorem is that prime number theorem? Is it called prime number theorem? What's the theorem called that you can break every number to prime? Huh? What's the theorem? Prime number theorem? Anyone remember the theorem or not? Huh? Huh? What's the theorem? That you can break any numbers into the product of prime. Any example? What's the theorem name? I remember. Okay. So consider the theorem that every number is a product of prime. Okay. So when I design this question here, right, it's actually considering the power of 2 and 3. Okay. Got name or not? No name. Oh, okay. Prime factorization theorem. Okay. Prime factorization theorem. Thank you. Okay. So it's a product of prime. So I put 2 to the power 3 here. Okay, and then put 2 to the power 2 times 3, and then 2 to the power 2 times 3 to the power 2, and then 3 to the power 3. Okay. What I do is I put 2 to the power 3 times 3 to the power 3. How I design this question at first. So I just play around with the power of 2 and 3. Okay. So here got 2, 2, 1, 1, 2, 2, 3. So I want to connect these 2 and 3. And then I don't want to connect these 2. So there's only power of 2 here. And then here only power of 3. And then I need to connect 4 of these together. So I need to take the LCM. Okay. So this is how this question started first. And then next, from this tensor diagram, we can ask whether there's a maximum element or not, the greatest element or not. Okay, maximum one, greatest. So some of you found the maximum element, but you say yes, there's a greatest element, but you don't put what is the greatest element. But I still give you mark. So make sure you know which one is the greatest element in the exam. Okay, you need to put down the greatest element. I think in the textbook, the question also write like this. They also write down what's the greatest element. I just following the way the textbook asks. Okay? Make sense? Okay? So you need to write down in the exam what's the greatest element. 1.4. Okay, this one is the totally order definition. Okay, so totally order. Some of you very good. You said that a tensor diagram is not a chain, so it's not a totally ordered set because totally order is every pair of elements that are comparable. Okay. Or you just find 2 elements that are not comparable. Okay. And then 1.5, find all the upper bound. I think most of you do this correctly. Okay. Some of you don't do it correctly, or some of you started with the wrong tensor diagram. So I just mark based on the tensor diagram you gave. Okay. 1.6 here. Okay, lattice. So the lattice is every pair of element has a least upper bound and greatest lower bound. Okay. So typically this kind of question, right? They won't ask you to check every pair one. Okay. So it should be there's a quick way to see it is not a lattice, or there's an easy argument to say that every pair have the least or have the LUB or the GLB. Okay. So don't spend time go and check everyone. Okay. So there should be a quick way to see it. Okay. So if you spend time go and check, then you are trapped inside the question. By the way, I can tell you there's someone that get full mark on this quiz. Yeah. Every section got full mark. So yeah. Don't try the hard way. There are simple way usually. Any question on first part or not? of you got 9 or 10? 9, who is Rita? Unrated. Fu Jingrui also got. Li Yanran on 9. And Liu Ke, who is Liu Ke? Liu Ke got 9. Liu Xin, not Liu Xin, Liu Hanling. Who is Liu Hanling? Okay. Pen Jiarui. Pen Jiarui? Okay. Ruan Qiu Zi. Okay. Yu Jiaqi. Okay. Yang Yaru. Yan. Okay. Dan Zhou. Rainy. Peng Xingyun. Wu Benghang. Okay, good. I think you guys did better in this question. You guys did. But graph, okay, let's talk about graph. Okay, so if you say if you can't do the Hessel diagram, then you cannot do graph. There's one student, what he do is, I don't know he or she, what he do is, he write down the definition of a bipartite Euler circuit, Euler path. I give marks. So as long as you demonstrate you know something, I'll give you mark. If you put if you put blank, okay, normally you don't know anything, so I can't give you mark. Okay. So this question says that consider the Hessel diagram of the pole set from the previous question as a simple graph. So you take that Hessel diagram as a graph. Some of you keep the labeling, up to you, but you can remove the labeling because I just care about the graph, vertex and the edge. So we can ask, is the graph bipartite? Okay, why? Okay, I think some of you, get trapped in this question. You go and keep arranging. So there's a theorem. You need to just color your graph. Okay, if you can color using 2 colors, then fine. But you don't need to say, this one is on the first partition, that side is on the second partition. You can do that, but you don't need to do so. 2.2. Determine the graph has an Euler circuit or Euler path. Okay, so you need to discuss both. I put 4 marks here. Okay, you should know me well now already. I put how many marks? You need to have at least how many sentences. Okay, so my idea is like Euler circuit, 1 sentence. Explaining Euler circuit, 1 sentence. Euler path, 1 sentence. Explaining Euler path, 1 sentence. But to explain the existence, you can draw it. Just draw it. Yeah. Okay, 4 marks here. Okay, just now we already discussed Euler circuit. Just go and count the degree of the vertex. Euler path, same. Okay, count the degree of the vertex. Not need go and try and draw it. Okay, after you found the right degree, only then you try to construct one. 2.3. Okay, this one, a lot of you get trapped in this question. Okay, you think that there's a K5 sitting inside there. Okay, at first when I design it, I also think like that. This is the question that I started design this question. So I want to design one either planar or non-planar graph. Okay. So it's not planar because if you move the vertex that's labeled by 18 or 12, okay, you move it out, then you will see that it is not planar. Okay. So you take this and then take it out. And you pull this edge away. Okay. So make sure next time if you see K5 or K3, make sure you can draw it as a subgraph first before you say it. Otherwise, don't simply say it. Yeah. Because if you try to draw the K5, you will realize that it's not enough edge for you, or the vertex is not compatible. Okay. 2.4. 2.4. This one is a bit bonus. If you don't know the definition, then sorry. If you know the definition, this is a bonus because this is the same as 2.1. Okay. Yeah. So whether you know the definition. Okay. So two, you can say that it's 2 because it is bipartite. Okay, good. No need to tell me why it is less than equal to 2 or greater than equal to 2. Because in the lecture, we say that every bipartite, the chromatic number of all bipartite graph is 2. Okay, you don't need to show me less than equal to 2 or greater than equal to 2. Where here is 2 marks here. So you need to tell me it's 2, and then why it is 2, since it is bipartite. Done. Okay. 2.5 bonus question. So can you draw a graph that's isomorphic but homeomorphic to the graph? Okay. So isomorphic, not isomorphic meaning the vertex can be the number of vertex difference or the different way of joining. But homeomorphic is just used by elementary subdivision. Okay. You can just add a point or a few points anywhere to produce the homeomorphic graph. Right? Understand? Understand? So you can just draw something like this, okay, or add more. But you cannot add line. Cannot add line. Okay, adding line is not homeomorphic. You cannot add line. You only can cut the edge. Cut the edge. Okay? Cut the edge. Cut the edge. Cut the edge. Cannot add line. Okay? Adding line is not isomorphic, also not homeomorphic. You cannot add edges. And what's the Euler characteristic? Okay, also 2. This is the number appear in the Euler formula. Okay. If you read my notes, then you will know. If you don't read, then you won't. Textbook doesn't have this thing. But I said it as a bonus. Okay. I think Rainy benefit from the bonus. Rainy benefit from the bonus. Yeah. Yeah. Yeah, graph question caught most of you. Okay. Any questions you want to ask? So exam type question will be very similar to the quiz question. Hey, Ethan, you don't wanna? How to say? See your homework lah. Okay. Yeah. What? Oh, okay. Want to change mark? Okay. Yeah. Okay. So, between now and before we finish, if you have one last question on the review question or this question or exam question, you can prepare. After this round, after I change the mark, then we will have the final last question before we leave.
这是少一分。
Yeah, okay.
我答案跟你一样，2.2。
你画 graph 吗？你有画 path 吗
2.2一样后边。
？No。
哦
path。
哦，sorry。OK。对。然后这个是风，它是里面如果比如讲像这个，我在这边加一个点，然后这样子算是吗？如果在楼下
还是 可是你这些填不进去哦。
哦，我记得，如果加一个点，
是。
可是如果是要 remove 点的话，
remove 也可以啊，你这边变成这样啊，这样也可以。对啊。
对，4个
对。
没了，
对啊，还要哪里？
这为什么是2分？
哪一个？
这不是1分，这不是2分。
算错吧。
好，这个。这个是我写出不是。
哦，对，
为什么？
应该要至少给你1分吧？我看看，你看看。
我最后才发现写错，然后只改一个，忘记改全部。
对，给你2分。
但是也是。
这个是错的，这个要有。
有。
对，
正好有2个。
对，没有错。你写 more than 算错。OK， 5分，对。还有吗？对，可以的。
这个为什么是1分？因为要写原因才有2分。
Yes。
原因就只要写是。
可是你
这个就。
对。OK， 可以的。OK， 好了，不要了。哪个？我刚才帮你加这个。加还有吗？还有吗？
还有这个我有，可以写文字阐述，就不用说2个。
可以，但是你没有告诉我它几样分哦。
就是把所有的东西都分为V1和V2。
我知道，但是
没有表现出来。
对啊。
都没有表现吗？一个是的 B 就外的。
我谁去这里都可以，对不对？对吗？还有吗？OK， 好，可以。
好的。
好，行。
这个 wrong age。
先加还是按顺序？不需要，没事。哪个？
这个 wrong age。
wrong age 对啊。你的 graph 是对的吗？
是啊。真的。
OK， 那天好像他是错的。
不是，这个点是中间这个点。
哪个？
最上面这个点是中间这个。
你看啊，我们这里有1 2 3 2 3 1 2 3 4 1 2 3 4。OK， 大家再给我看一下，1 2 3 4 5 6 7，1 2 3 4 5 6 7 8，对，8个。然后我看一下，对，你把这个拉出来，这个点是哪一个？
最上面的。
上面这一个。这2个是这2个。
哦。
OK， 我觉得可以。可以。OK， 这个是2分的。OK。OK。
对，这问号题就不能出。
哪一个比较上面？
不知道。
华语可以这样讲，哪一个比较上面？是哪一个比较大吗？来，华语也不对吧？我觉得哪一个比较上面？对吗？我扣你那个吗？
没有扣。
对啊，没有扣啊，对啊。
第一个词。
学一下要用这个词。OK。OK。
我圈起来看一个人。
因为12和18的 lower bound 是它。upper bound 是216。
不是 this type of 为什么会有人是吧？因为他们俩不是的。
没有，他们的 upper bound 是216啊。
我指的是 this type of。
对啊，this upper bound 就是它，因为它有一个。 啊，它是小于所有的 upper bound，它就它自己
所以它们俩之间的 upper bound 就不包不上了两个。
啊，对，
但如果是
有时候可以包，比如说它一条线包它两个，不用，这样它就会包括 upper bound。呀，这里的话就216本，然后216本身就是那个 lower sum。
所以这个23的就是23之间就是没有那个
yes，
lead cover。
没有加分还是有加分？
这个我不知道对不对？没有，
这个没有改变啊。
没有改变。
啊，还是什么一样的 identity。这个有，这个哦，对，我刚才说给你几分？2分，下次你要写出来啊。有这个上面你不可以，因为你把一条线丢掉了。对啊，你就把线丢掉了，不可以了。我们只可以加点或者把点拿掉。把点也行，但是不可以把线，也不可以加线。OK， 吴金瑞啊，对 ，OK。
那里3%。
这个要多少分才可以算上那个4年？
它这个
就是你能折算点。
哦，上次你问过我这个问题。
对。
我要查一下。你是说你要 final 要考多少的电脑是？我查一下。
你的这个1分，就是这个。
OK， 刚才我给你了。OK，
这个有机会给1分吗？
没有，真的没有东西不能够给。这个我以为是星星啊。OK 啊。诶，怎么你的分数？哦，我看错了。OK。呀。
3秒呢？2分吗
？OK，这个吧。就是你为什么搞乱？你很可惜耶。
很可惜。
实在是可惜。你就哪里会？
我只是写到什么，我记错了。
这不可以记错的，你不要用记，你要用理解。这个 to 这个 exactly to 就是拿来做 Euler path 的，知道吗？
现在知道。以前是知道，可是考试忘记了。
你不可以只是记罢了，你要理解，可以吗？要理解，准些。这么对要答案，就请你换一下就错了。是啊。很可惜耶，不可以死记耶，有理由的。
我都是20分，
哪一个？
你看这个为什么？我都是10。这是谁？
你有前面那个头。
不是，你看说知道就可以给分，我知道。
你知道什么？你犯6，你知道什么？
我知道。
你知道什么是6？为什么6？
我知道触看了。
你知道你问题你没有放在这里。
我只是不认识他。
你不认识他，他也不认识你。
没有这个我知道，你看是不是？我写这个，我知道。
不能，我也是没有给分的。
我知道。
因为我没有给人家分，我写这个。
他
可以啦。
我知道。可以。我也可以的，我知道。
我也是知道。
我不跟你讲了，不可以的，我没有给分的。
不是，你刚才说你
知
道就给分，是不是？
你不知道。
写到旁边这来还知道，真的。
这是我的风格，
这是我也知道，是不是？
知道，但是问题你不知道这个。
单词就不能用那个什么看了，就不能换个单词。
就是那个单词啊。
还是弄出来的错呢？
你能赔吗？
或者是
啊？
对，一辈子的第二个
颜色啊，那颜色。好吧，这个6哪里来了？是啊。
知道我们2个都一样。
是啊。
我也不多，上面题我都看
免
不懂。
费的分。
我是不是？我知道了。你刚才说知道有分，
但是你不知道这个。
哎，知道了。
我知道你不知道，我知道你不知道。
有这样算了，就差1分就。我知道。 没有，把它吃完就转过去变丢了。
对，这样啊。
哦，对，那对，就少一分。关这分数
OK，那我们
就是我可以记一下我全部亏损分数啊。这边有
可以啊，你没有拍吗？以前
没有？
你前
之前有说过没？
还有这个
之前你有给我们看过没？
我没有给你看过，但是来你们每次都有拍一个来着。
没有，没有。
我给大家看一下，
你们上一个 overall 的
就是
等一下咯，等一下。
10分，我操，有些
是八
在哪里？
八，
哦，
他
不
这个
知道后面。
这个
14，然后16、30、35。
1088 54 4588 10，
是
80，
没有他
25、35啊
会不会多少？
，35啊。
50哦
那是我的。
，50乘16嘛，
我们
148先，
发现
16，有25、
没有乘20 ，sorry，
35和50。啊，没有到40。
我是我的。
没有，你还要再加你的那个，
你考这个成绩，
你要加那个
它是会占
28先吧，
会占20%，很多啊，20%。
你还要加那个30%。
难看啊。
等一下再看啊，先解决掉问题。
18，
怎么？你要干嘛？
啊，
你要干嘛？你要干嘛？
那就不在里
哪里？
18。
我没有讲你指点我。
生气，
来，
不一定。什么？这样给你分错啊？没有，这是错了。
你这是干嘛？
这是你写的。
哦，因为你的这个你自己算一下，你看你自己
可是前面看起来同一个没？
不可以。
怎么？因为很明白嘛，
也是错的，
因为他前面错了。是啊，因为他讲
前面错啊，但是问题是，
找那个 diagram 嘛。
对，这个是 base，但是这个不 base。
什么？
你看它漏了这条线，漏了这条线，漏了这条线，
那这个
然后又漏了这条线。对呀，你画错图啊。
对，可是3分是解释不是啊？
没有一个 Euler circuit 2分 Euler problem。
也是他讲他没有 other circuit。
对，
对啊，然后
然后它也没有 exactly two 啊，所以你其实是画不出的你。呀，你是画不出的，你这个 Euler 差是画不出的你的题，因为你有4个 odd degree，所以我根本都不用看你在画的。
你算错了。
是啊，
因为3right。啊，对不对？
没有，你看它 original 图，1、2、3、4个 odd degree。
啊，所以如果这个 based on 这个话，过后它写对了就可以拿。
可以啊。
哎呀，算错了。
对啊。
然后这个，如果他要解析一下，没有出来。他这样可以记错。
哦，at least two。
因为你扣我1分嘛，这个我知道。
因为你说，因为它至少有2个点是连在一起的，所以它需要 at least 2 color。
我要讲至少有2个点是连在一起。
比如说有3个 color 的话，就因为它有 triangle， 如果有4个的话，就有那个这样子的 complete graph。OK 吗 ？OK。
对，如果有2个话怎么讲？
如果2个的话，因为它有2个 vertex adjacent， 至少2个 vertex adjacent。啊？因为
有这个你讲这个我至少2个。
是啊，2个，因为
他是少过他的 K 少过
大于等于
K 变咯。magic。哦。
OK。
因为老师这个
那个 OK。
这个 intern， 它不是没有球还是 intern 的计算？就是我们对
S 跟 C 都有没有位置？
就是这题B intern。
呀，我讨论了 before 我们走先。Okay, last thing before we leave. Okay, before we leave. Okay, before we leave, okay, before we leave, okay, there's one question from 11.4, right? Hey, who is getting the Li Yanran's paper? Who got Yanran's paper? Who got Yanran paper? Anyone got Yanran paper or not? How she got it her paper? Who is getting Li Yanran paper? Or you? Okay, you put it back already. Okay, later I need to. Okay, 11.4 point what? Huh? 1.4. Okay, your question is why? Who is internal? What's your question? What's your question? Yeah. I mean, what's the question about? Yeah, what's the question? Something is wrong. Which one is wrong? Wrong. Yeah, which one? Which one? B is wrong. C is not internal, huh? Good. Yeah, okay. So let's change it now. C is not internal. A, B, C, D, F also not. Yes, F also not. Who else? G, H, I. That's all. Okay. So leaf need to add C and F, is it? Oh. Ancestor of M. Descendant wrong. Ancestor, okay. So descendant of B is E, J, K. Oh, F also got. G also got, A also got, M also got. Okay, good. Good, good. Just now got question from there. One question just now. Any question? Huh? Tutorial question or what? 16, 11.1.16 ah. Which one? Huh? Chapter. What chapter? Banning tree. And then? 11.3, huh? 0.4, 0.16. Okay. This one wrong. Huh? JJ. Oh, JJ. JK. So which one is K? The lower one. Okay. J. JJ. Okay. How's anything else? Anything else? Using right? Yeah. Okay. Yeah. Yeah. Cannot delete edges, but can delete vertex. But when you delete the vertex, you only can delete the vertex that's lying on. Okay, you only can delete the vertex with degree 2. Okay, so for example, this one is homeomorphic to this one. Okay, you only can delete vertex of degree 2. Okay, because they are coming from the elementary subdivision. Okay. Any more? No more. And everyone signed the list already? Where's the list? Pass back to me already. Okay, I got it. Any more questions? Huh?
Yeah, we can't remove right for the what is it?
And then just now I remove right. Then you can remove. Oh, they are degree 2 vertex, so you can remove. Yeah, you can remove. There's 2 vertex you can remove. Other question? Any more question? No more. No more. No more. No more. If no more, then good luck in your finals. Okay, hopefully I don't see you again. I mean, in the same class. You guys want to take a group photo? You guys want to take a group photo? Okay, since we have Fei here, Fei, tell us to take a group photo. Take a group photo. Okay.
这个电话来的，
跟我刚刚电话一样哎，走过来的，走过来的，走过来，走过来。谢，我们又用了电话。
No, everyone just sit on the. Everyone just sit. Sit on the table.
老师不够哎，不够哎，太大了。
是那边的这样子。
这不够呀，
这样不能进的。哪里那谁不能进这样？这样
旁边的两边都要去中间。
那边也看不到。
这样子这边要过去
啊，这样不这样不做。
就这一排，就这一排过去。哎，那边同学，望这边，望这边。现在会有点看不到。
后面
对，可以站起来，后面可以站起来，这样可以站起来。啊，那边后面也是看不到。
哪一个后面？
后面两排，后面两排，对。
口罩可以摘掉，我要。
OK。
哇塞！
一，三。 1、2、3。OK，再 freestyle 啊！1、2、3，然后再来吧，你们。OK，我再看看吧。
反正就这样了。OK，来。Oh yeah, yeah. Can give me back your quiz. As you.
看见，哎，这个是 depth first，这是 depth，所以你可以要尽可能多，对，要尽可能点多，但是就算你连了 hash 也没问题，但是你这条线就要变，比如说你连了 hash 之后，然后你从这里过哪里，这个这条线直接可以去连起就。Thank you, Seng. OK，来，Thank you。啊，这两个探索，你给我看一下。对，double pass triple plus 吧，好像是 triple。是 double 啊？我解错，但是我讲的东西是 triple。我解错，但是我说的东西是 triple。就是你的 continuous assessment 要40，然后你的 final 要40%，然后你的
continuous 是啥？
continuous 是continuous 是
那你是哪一个？
没有错，没有错，没有错，就是你要
就他们全部换算成100%，然后乘40%。
yes， 对，没错。OK，拜拜。
就是三项每一项都要到那个100分，
最后一项要55，
最后一项要55，然后前面两项是要40%。
yes。
哦，谢谢老师。
等一下我搞一下那个定义，确保没有讲错。
加上你的 WeChat，
对啊，你没有加过我吗？
加了，然后你可以发给我。
哦，OK，对。
这样，
觉得都可以走的。
那个深度和那个宽度，它两个探索的有什么不同？
什么再说一次？
就这个深度，一个 depth，一个是宽度，一个 width
啊，对，
它有什么区别？
因为一个是直接从一个点把所有的点都加进去先，然后另外一个是从一个点一直加。
哦，分开对吧？一个只有2值，一个是多值，一个只有2个分值，另外一个是多个分值。
不是，你看它的加法，它一个点，然后下一步它是直接把所有的周围的那个 edge 都加进去，然后这一个是一个
先加一边，然后再加另外一边。
对，你看它没有的，它不理的，所以你可以去 hex 先，但是你会造出不一样的。
不一样是大的，所以这个是先走一边，然后再走另外一边。深度的，就是他先走了，先找这边，然后最后再找这边。
都行。你刚才问的问题是你不可以走这条嘛？我说可以，可以走这条，
OK，
然后就
OK，
呀，你不要继续走到平为止，然后你再回去，然后再走。对呀，哎，
他也是要加，
也是有问题，没有啊？有问题，还有问题。
不是你的 Android 给我照片嘛？
可以啊。好，谢谢。要我
那个 AirDrop 那边啊，我名字啊，我叫 Alan。
你是数学转过来的那个吗？不是，
他是今年的新生。
哦，你是今年。你们坐后面的。
AirDrop。 结束。I think
我们多哈，
对，有。OK，谢谢老师，
拜拜，加油。耶，
为什么
啊，
为什么这个
哎
就是它这个两个横着的
啊，
不是已经能覆盖所有的了吗？
然后呢？
但是为什么它还要再有一个
哦，
那个呢？
没有，这个画只是我们把所有的 prime 都画出来。
把所有的 prime 都画出来。
prime 这个，把所有的 prime 都画出来。
那就是说我竖的这个可画可不画是这个意思。
你记得刚才有一个例子吗？就是我们有可能会取到它的。第二这个例子嘛，我们要把所有的可能性先画出来先。这个例子，你看，你如果可画可不画，有些没有画出来，可是你等下看漏了怎么办？
我觉得其实这个题目有个取巧办法，
Yep
就是你先用眼睛把这个式子算出来，然后你再去画这个 King map 就会比较好画。
可以是可以，但是当你不能用眼睛的时候，你怎么办？
用眼睛不是很简单吗？
如果有100个词放在那里，
那老师你出这个题目你改了也没事。
不是，这个不是出题的问题，这个是一种
应用
思考的方式。
中国人的应试教育是很强大的。
我知道，但是问题是，现实中可能有1000个人。
我又不学数学。
I mean 可以啦，可以，你可以走捷径。
那也就是说，这个，
但是如果你不画出来，你没有符合那个步骤，你明白吗？
那我这么画对不对？
错
啊？
要把所有的可能性看出来。
为什么？我只要能够表示这个式子，我就可以了。
是的。OK， 但是如果你因为这样你错掉，这样就没有办法，救你。
什么意思？
就是如果你画漏了，导致你算错
啊，
那就
我已经知道答案了，我去画这个。
那你知道你的答案可能不是最终答案。
那不一定，我觉得这个方法非常好用，这个方法能直接用眼睛看出来所有画 K map。
我不知道，但是我就只能告诉你，如果是错的话，我就不能够用这个步骤来帮你哦。
错了就是错了。
如果你愿意承受那个风险，就
那为什么这个他就不用呢？这个图他就不用在外。
要的，其实是要的。它这是什么来的？
也是一个式子，然后用 K map 来表。
这是什么例？这是例子还是？
这是 textbook 上的。
这是例子还是什么？
例子吧。
这是例子哈。因为有时候可能比较直接，因为这里的你看，这些都是 essential 嘛。你看这个不 essential，你怎样知道你要丢哪一个先呢？你知道哪一个丢了对你比较好啊，还是什么？就是其实你要画也是可以画，但是他如果不要画的话，为什么呢？因为你看啊，如果你画上去，不是你要拿的也是这些 essential 的，懂是吗？
听到
OK， 就是如果画上去，是不是它还差2个，对不对？
就是假设有这个。
Yeah，但是它为什么可以丢掉？因为可以看得出这些是 essential 嘛，这个不 essential 嘛，可以看得出，可以理解我讲吗？
啊，对。
但是你看啊，这一题啊，没有一个是 essential。
对
啊，所以如果你说啊，可能这一个够啦，已经够 cover 啦，然后可能把这个值的丢掉啊，那我不知道啊，我不知道。
就是说，没有这个已经够 cover 所有的，但是他又必须得画这个，是这个意思。
啊，然后对，
就是
然后呢？对，
不会也跟我说懵了。
OK，不然我画一个给你看。假设我画这个 ，OK， 然后我画这个，OK， 我画这个 ，OK， 我不要画这2个了，可以吗？
可以。
那你看现在这边有几个圈？1个圈、2个圈、3个圈、4个圈了。
对。
难道这个答案是4个圈吗？
三个，
只有3个啊。
嗯，
因为我们可以透过这2个圈再缩小一点，可以明白吗？
为什么我加2个圈，我不是变成了5个了？
啊，对，但是你从5个里面可以再找一个最优的3个，但是你从这4个里面，我不觉得你可以找到最优的3个。你明白吗？你明白吗？但是你刚才有一个前提说啊，我用眼睛看它只有3个，这样我把这3个圈出来就好了，这样子 OK 啦。但是如果我就说，如果你算的是错的，然后你这边又给的是错的，那你就连这边都没了。你呀，你呀，
啊，
啊，
但是就是为什么就是我
他这个不画的话，应该是蛮明显。那我这一题是蛮明显，是因为如果你加上去啊，你看你这所有的 essential 的 prime 其实已经包含你这些 prime 了。
那我到底要根据什么来判断？
画就画就画吧，就画吧，
就是
就画吧，
就画就没风险。
就没风险。如果你不画，你要知道为什么你不画，不可以随便不画。
哦，但是我画就不会扣分
当然了，
啊，
对不对？
因为这个当时就是
啊，
这个就是我当时就很疑惑，因为
对呀，
我把这个式子用眼睛看出来之后，我觉
对
得只要画这2个圈就可以了，
对对
但是他又画了一个圈。
对对，你要知道为什么你不画。你不可以随便说啊，反正我 cover 完我就不画，这个是错的，肯定啊，这样，OK 啊，谢谢
是那个刚才
啊，
我刚才就是最后问的时候，库其实可以 remove point。
哎
对呀，
哎，你看这边是 degree two 吗？可以丢掉哈，跟你讲，degree two 吗？可以丢掉，跟你讲，degree two 可以丢掉，跟你讲，对不对？
老师你先讲
，OK，
突然想起来一个事。
可能我要回答他一下，他在卡很久，OK 啊，
然后
嗯，
就很短很短的。
啊，你说
老师，如果是 sub tree 嘛，是
啊，你继续
我们不一定要画完全部的，对吗？我们还只是可以画，我们画小部分的也可以，对吗？sub tree。
不能啊，sub tree 的话
sub
一
tree
定是整个线是，它没有不一样的 definition，它就整个向下
这样 sub tree 其实我可以理解它是 proper 的，对吗？
啊。
我可以理解 sub tree 就是要 proper 的嘛，因为之前老师说 graph 我们有 proper sub
啊，对
proper
，sub tree 就是 proper，
sub tree，所以说如果 proper sub tree of the root，我们就一定画完全部。
root at 一个点是吗？
就是如果它最上面那个就是它的 root 啊，root at
嗯
A，我如果要 sub tree of A，我们就要画完全部。
，yes，A 下面的东西全部都要换。诶，这个学生的纸我不知道我有没有，哎，他朋友不知道有没有还给我。Oh, can you hear me? Can you hear me?
还没有时间去找老师。
哪一个今天？哦，拜四啊。
presentation 回去换衣服。
哦，OK，拜四啊，拜四，对啊，拜四啊。
应该也没什么问题的。
对啊，
因为我是周三星期有周六，
这学期
这个星期我还没做。
还没做，是不是啊？你要问什么？
老师，你不是说
嗯
画这个还是这个圈的问题？就是这个圈，你不是说要画的又少，但是它每个圈又能是最大的？
啊，对，
那如果你这样多画一个圈，不就是不
那个画的最少要选最少的组合。没错，
就是你多画了一个这个竖着的，你不就相当于多画了一个圈？那我不画这个，我还是
不，就是这个是没有，那个最大最少是找啊、足够的那个 足够的 prime implicant， 你要先找足够的 prime implicant 先。你是再回去这个对不对？就5个里面你找得到最优的3个，但是我刚才选的那4个不是你找不到最优的3个，你最优只是4个，但是它答案不是4个，
答案是3个。
对，你明白吗？你要把所有的可能性放在一起看，你明白吗？呀，所有 prime implicant 的可能性放在一起看。
哦，因为它这个也是 prime implicant，
但是
所以我要把只要它是 prime implicant，我就要把它画出来。
对，没错。
那我什么样不画呢？就是它不是 prime implicant，
对，它不是 prime，
我就可以不画。
对，比如说对，比如说这个变化，因为它躲在另外一个，如果你这2个已经把它包括了，那变化里面
因为这个是 prime implicant，所以
对，
它必须画这个。
必须画，因为它有可能性可以组成你的 function， 它有可能性。
那就是如果说他用 K-map 来表示一个像比如说像这个的话，我一定要画这个圈吗？还是说我只要把一标出来就可以？
有一个
我坐旁边那个，他说如果用 K-map 来表示的话，我问他，他说
K-map 一开始是长成这样吧？
对，
对，
他说那什么时候要画
圈？是要拿来 simplify 的时候，拿来简化的时候。
那题目只是说 use K-map 去表示这个式子就不用，但是要 simplify 就要画圈。
他可能讲 use K-map to find the minimization of the。
那就要画圈。
Yeah。
OK。这回真古板，没问题。
可以。在 email 有问题啊。好，拜拜。走吧，拜拜。
对，拜拜。
好，拜时见。
有问题的。
OK，拜时见。